The US military is thinking about buying Elon Musk's Starship from SpaceX to use as a military platform. And when you think about it, it makes a great deal of sense. Now, we're not talking about turning the Starship into the Space Force's first orbital fighter or using it to launch missiles at adversary nations, but rather in a way that could actually win wars as a massive strategic advantage in logistics. So let's talk about the Air Force Research Laboratory and Space Force's plan to use SpaceX's Starship to deliver emergency supplies, military equipment, and maybe even troops anywhere in the world in about an hour or less. And if that sounds like science fiction to you, you may be surprised at just how close we already are. I'm Alex Hollings, and this is Air Power. Now, regardless of how you feel about Elon Musk, it's tough to deny the fact that SpaceX has changed the way that we think about ferrying cargo loads into low Earth orbit. And SpaceX officials, including Musk, have been talking about the company's long-term vision of fielding a heavy lift rocket since before the first Falcon 1 rocket took off all the way back in 2005. But now, with SpaceX's Starship completing 3 test launches to date, it looks as though this long-term vision is rapidly becoming a current-day reality, and that has huge implications for defense. Not only does it make it possible to carry larger payloads into low Earth orbit and beyond, expanding both the size and the scope of orbital assets that the defense and intelligence apparatus can put into orbit, but it may have an even bigger impact right here on the ground, as a part of the US Air Force's heavy lift capabilities. Because despite all the attention we place on cutting-edge new stealth fighters and advanced new weapon systems, America's most potent strategic advantage is hands down its logistical capacity. The United States maintains fleets of surface vessels and aircraft dedicated to moving large amounts of personnel and equipment all around the world every day on short order. And I'd contend it's the US's ability to do this that keeps adversaries up at night, more so than any individual new aircraft or weapon system in development. But there's a problem, or maybe 2 of them. The first is that the US Air Force's heavy lift cargo fleet, which is made up of around 500 aircraft, half of which are C-130 Hercules, which are still in production, and the other half of which are much larger platforms, with around 220 or so C-17s and more than 50 more massive C-5M Galaxies. Both of these aircraft have been out of production for years, which places the Air Force in a tough spot. As these airframes get older and age out of service, they need to be replaced with something. And you would need 4 C-130s to replace the cargo capacity of just a single C-17. And the other problem really applies to all cargo aircraft, and that's speed. Now, moving your hardware from one corner of the world to another using aircraft is the most expedient method we've got. But let's say you wanted to move a Patriot launcher from San Diego in California to Okinawa, Japan. Now, using a C-17, which is one of the few platforms that could actually carry all that hardware, you could take off from San Diego and conduct mid-flight refueling all along the way to make sure you got a direct flight to Okinawa. But that 6,500 miles or so would still take more than 12 hours to cover, which is certainly quick, but sometimes not quick enough. And that is where Starship could change everything. Because the SpaceX Starship could not only carry potentially twice the payload of a C-17, but it could cover that same distance in about a half an hour. Now, when it comes to size and internal volume, the SpaceX Starship is actually pretty comparable to a C-17. The C-17 stretches about 174 feet long. The SpaceX Starship stands about 164 feet tall. The C-17 has a cargo bay that's 88 feet long and has an internal volume of around 20,900 cubic feet. The Starship's cargo area is a bit shorter at just 56 feet long, but has a larger diameter, providing greater internal volume, around 35,000 cubic feet. Now, to give you a sense of just how big that is, a single C-17 can carry 10 up-armored Humvees. But from here, the Starship takes off, if you'll forgive my pun. Because while the C-17 is powered by 4 very big Pratt & Whitney F-117 turbofan engines that produce a combined 161,000 pounds of thrust, Well, Starship's Super Heavy booster includes 33 liquid-fueled Raptor rocket motors that produce a combined 16.7 million pounds of thrust. And then once Starship separates from the booster, it's got 6 more Raptor motors on board that can produce 3.3 million pounds of thrust, all on their own. And as a result, while the C-17 tops out at a bit north of 500 miles per hour, Starship can do better than Mach 20. In fact, it needs to be doing about 17,500 miles per hour in order to enter low Earth orbit. But rather than deploying satellites, it could just circle to where it needs to before beginning re-entry and coming in for a vertical landing wherever that cargo is needed. Now, obviously, this wouldn't be a good replacement for heavy lift cargo aircraft, but it could be an incredible supplement to it, providing emergency relief after disasters, or replacing vital capabilities on the battlefield that have been taken out by enemy action, like, say, a Patriot air defense system. You could have a new one delivered from the States in about the same amount of time you might wait for a pizza to be delivered right here at home. And that combination of capability and adaptability is a big part of why the DoD is thinking about purchasing this platform from SpaceX rather than contracting this work to SpaceX. And that also provides some much needed insulation for those who are concerned about Elon Musk's erratic behavior. If the Air Force, or the Space Force for that matter, own the starships that they operate, it doesn't matter what Elon Musk has to say, the same way the Air Force doesn't consult with Northrop Grumman's CEO before launching B-2 operations. It would simply be another tool in the toolbox. And it's one that both the US Air Force and Space Force are heavily invested in pursuing. In 2021, the Air Force Research Laboratory kicked off the Rocket Cargo Program, which was heavily influenced by conversations with SpaceX about Starship. This effort aims to move 100 tons of cargo anywhere on the planet in what the Air Force considers to be tactical timelines. And the concept is so promising that the Air Force has classified this effort as one of its 4 highest priority Vanguard technological efforts. Now, Air Force Vanguard programs aim to rapidly field groundbreaking new capabilities that can give the United States a significant strategic advantage. And Vanguard efforts are considered to be the highest priority in the force, meaning the Pentagon sees this rocket cargo program as similarly important to these other Vanguard efforts, which include the Golden Horde, or swarming munitions, the Navigation Technology Satellite 3, which is sort of a next-generation GPS satellite, and Skyborg, an effort we've discussed several times on this channel before that aims to field AI-enabled drone wingmen that will fly alongside the next generation of fighters in active development today. The following year, in 2022, the Air Force Research Lab awarded SpaceX a $102 million 5-year contract to continue to mature and demonstrate technologies specific to this role. I'll quote the commander of the Air Force Materiel Command, General Arnold W. Bunch Jr. Rapid logistics underpins our ability to project power. That is the fundamental motivation for initiating the rocket cargo program. We see its initial application in swiftly restoring operational capability for forces forward in austere environments, as well as dramatically reducing the time required to deliver crucial humanitarian assistance and disaster relief. But of course, it's not all good news. Making the rocket cargo program work would mean overcoming some massive engineering challenges and a fair share of political ones as well. One of them, of course, being about SpaceX's controversial CEO, Elon Musk, and the idea that this program could embed the eccentric billionaire even deeper into America's defense apparatus. And that's one the Air Force Research Laboratory seemed to be engaging right from the jump when they wrote in their initial press release, "Logistic speed is at the heart of military supremacy. If a commercial company is in advanced development for a new capability to move material faster, then DoD needs to promptly engage and seek to be early adopters. That is the fundamental motivation for initiating the rocket cargo program." And to avoid putting all of America's rocket cargo eggs into the SpaceX basket, the Air Force Research Lab has also signed cooperative research and development agreements with rocket Rocket Lab, Blue Origin, Sierra Space, and the Exploration Architecture Corporation to exchange data and information regarding point-to-point rocket travel capabilities. And of course, cost is always subject to political debate when it comes to budget allocation, and historically speaking, rockets tend to be a whole lot more expensive to operate than cargo aircraft like the C-17 and C-5, though this is one area where SpaceX has already made considerable progress and intends to make quite a bit more. And a lot of that has to do with advancements in reusability. Rockets used to be a single-use application, but SpaceX's Starship aims to be completely reusable, with both the Super Heavy booster and the Starship itself landing on their own to be refueled and used again. And this has really shifted the cost proposition for using rockets for these sorts of applications. Back in 1969, every Saturn V launch cost the US government a reported $185 million, which, adjusted to today's inflation, shakes out to about $1.62 billion per launch. And despite the space shuttle itself being reusable, in 2010, it was reported that every space shuttle launch cost the US government an average of $1.5 billion, which again, adjusted to today's currency, shakes out to about $2.16 billion per launch. Now, the space shuttle could deliver a maximum payload to low Earth orbit of about 65,000 pounds, which is a bit more than the SpaceX Falcon 9 today, which tops out a bit higher than 50,000 pounds. But the SpaceX Falcon 9 only costs about $67 million per launch. That's 97% less than a space shuttle mission. And in fact, for the cost of a single space shuttle launch today, you could launch 32 Falcon 9 missions and still have change left over. Or to give you another basis for comparison, in 2011, it was reported that using the space shuttle to deliver payloads to orbit cost about $25,000 per pound, which, adjusted to today's currency, shakes out to about 35 grand. Whereas today, it only costs about $1,500 per pound to deliver payloads using the Falcon 9. And because both Starship and its Super Heavy booster are meant to be reused all but indefinitely, Elon Musk has claimed that in the next 2 to 3 years, each Starship launch will only cost about $10 million, and he further claims that eventually that launch price may drop to as low as $1 to $2 million. Of course, Elon Musk saying something doesn't make it true, but this capability could be so potent that the Pentagon seems to believe that it's worth taking that bet. And I can see why. If Elon Musk manages to deliver on that claim, it would mean that launching the Starship wouldn't actually cost all that much more than flying America's largest cargo aircraft from one side of the world to the other. According to a report released by the Government Accountability Office in late 2022, it costs about $30,378 per hour to operate a C-17 and about $57,508 per hour to operate the larger C-5M Super Galaxy. Now that means that it would cost about $455,000 to fly a C-17 from California to Japan, or about $862,000 to fly a C-5. And that's without considering the operating costs of the refueling tankers that would need to meet them periodically throughout their journey. Now, that hypothetically means that Starship could cut that 15 or so hour trip down to well under an hour for only a few $100,000 more, which is certainly a lot of money, but it's worth noting it costs about $173,000 per hour to fly the B-1B Lancer. So you could get your cargo to the other side of the world 30 times faster for about the cost of 1 hour of bomber operations. And that possibility, while seemingly unlikely, is absolutely worth exploring. But let's say all this does prove to be true. We still need to overcome the engineering and logistical challenges associated with receiving this cargo on the other end of the launch. And that is something that the Air Force Research Lab, Space Force, and SpaceX are exploring multiple avenues to address. SpaceX and other commercial enterprises like Blue Origin envision fixed point-to-point transport between established pre-built launch sites all around the globe. Now, this would be the simplest approach technologically speaking, but would also come with a pretty steep infrastructure requirement and the need for further logistics to get that cargo from the landing point out to the austere environment where it's needed. But to be clear, these challenges are not unique to rocketry. Not only do all cargo aircraft require maintenance and logistical support, but landing a fully loaded C-5M Super Galaxy requires a well-manicured 1.5-mile-long runway, meaning any cargo delivered via this sort of aircraft would also need further logistical support to get that equipment out to austere environments. But I'm going to quote Greg Spangers, the Air Force Research Lab's program manager for the rocket cargo effort. He says that the DoD is very interested in finding a way to deliver this cargo directly to the austere environment, especially when it comes to disaster relief. Quote, "We are therefore exploring a wider range of novel trajectories to mitigate overflight issues, exploring a broad range of landing options for austere sites, researching human factors when landing near populations, and integrating a broader range of cargo, including medical supplies." And this isn't entirely infeasible. Starship is, after all, designed to land in the very austere environments of Mars. And according to SpaceX, while it does need its Super Heavy booster to ferry massive payloads into orbit and beyond, it can travel north of 6,000 miles under its own power, meaning, theoretically, you could refuel this rocket and take off again from an austere environment. But if you ask me, the most logical solution is simply not to land during the cargo delivery at all. Instead, it makes a lot more sense, in my opinion, to deploy the payload in its own re-entry pod, so to speak, before continuing on to the next closest established landing and launch site. And while most conversations revolving Starship as a logistical capability tend to center around the rocket actually landing where the cargo needs to be delivered, it turns out this is also an idea that the Air Force Research Lab is exploring. As Rocket Cargo Program Manager Greg Spangers explained when asked how to get Starship's logistical costs down to on par with the C-17, he said that if the SpaceX Starship launch tempo gets high enough, it would be pretty easy to just launch cargo containers while the rockets are still in orbit. I'll quote him here. "We can insert cargo transport as part of their regular launch rate progression and treat it just like another satellite in their flow, or have contracts in place where we can inject it into their flow. That's where we can bring the costs down by an order of magnitude, and where it starts getting extremely attractive." And arguably to that very end, Justin Fiaschetti and Austin Briggs, both propulsion engineers formerly from SpaceX and ABL Space Systems respectively, started their own company in 2021 called Inversion, raising $10 million in seed funding to begin development on a fully reusable re-entry cargo capsule for just this sort of thing. And who knows, either of these avenues could ultimately see a resurgence in things like the Marine Corps' 2005 Small Unit Space Transport and Insertion, or SUSTAIN program, which aimed to field, and I kid you not, single-stage-to-orbit Marine Corps transports that could deploy squads of 13 Marine riflemen with all of the supplies they need to anywhere in the world in 2 hours or less. Even 20 years ago, this concept was considered technologically feasible, but was hindered by the fact that it would have required, quote, enormous R&D budgets. And while there is no disputing that, a great deal of that research and development has since been completed by SpaceX, largely via government contract. And while the idea of turning the Marine Corps into Halo's ODST helljumpers may seem like science fiction, I can't help but remember that when I was a kid, the only way you'd ever see a rocket take off and then come back down and land on Earth vertically to be reused again was in science fiction. Listen, full disclosure, I am not a proponent of injecting Elon Musk, or any billionaire for that matter, deeper into the defense apparatus than maybe the role of CEO of a prime defense contractor. And that's why I would like to see the US government purchase Starships to operate on their own, rather than contracting all Starship operations through SpaceX. But at the end of the day, it doesn't really matter what we think of Elon Musk, or even of SpaceX and its platforms, because what SpaceX is really doing right now is proving that this concept is possible. For all we know, SpaceX may ultimately prove to be the MySpace of commercial rocket applications, helping to usher in a revolution it doesn't last long enough to experience for itself. But it ultimately doesn't matter what logo is on the side of the rocket. If this capability could turn the tides of a battle, if it could save the lives of men and women in uniform, and it could do it in an economically feasible way, well, then the Pentagon not only has a duty, it has an ethical obligation to explore the concept. On October 9th, 1903, the New York Times published an editorial entitled "Flying Machines Which Do Not Fly" that infamously predicted that it might be 10 million years before mankind developed the technology required for powered flight. And of course, just about 2 months later, the Wright brothers made history with the first powered flight, covering only about 120 feet. Just 63 years after that day, Apollo 11 made history again, this time covering 953,000 miles, enough to deliver human beings to the surface of the moon and get them back again safely. And while the idea of using reusable rockets to support military logistics operations, or even to deploy troops, may seem like utter science fiction to me, I am acutely aware that that's exactly how the New York Times felt 121 years ago. So do I think SpaceX's Starship could mature into an absolutely game-changing strategic capability? Well, the evidence suggests that it is possible. But just like the Marine Corps' Sustain program that aimed to deploy Marines to battlefields around the world using single-stage rockets, possible and feasible are not the same thing. And while Starship does offer the promise of potential feasibility for these concepts, the only way we'll ever actually find out is to wait and see. So this is one program I'll definitely be keeping an eye on. And with that ends yet another edition of Air Power from Sandboxx News. I'm Alex Hollings. Make sure to swing by sandboxnews.com today and every day for all the latest in news, entertainment, and motivation from all around the force. If you got anything out of today's video, make sure to click like and subscribe down below, and leave me a comment so I know what I should cover next. And of course, don't forget to tap on that bell icon so you never miss a drop from Sandboxx News.